In this video, we are covering ratios and rates. This is a VL-612. Let's begin. So, what is a ratio? A ratio is a comparison between two different kinds of quantities or numbers, two amounts of things. What is a rate? It's a special kind of a ratio where two different units of measurement are being compared. Examples of rates include things like miles per hour. You might have like feet, which measures distance also. Per second, again, measures time. You could have dollars, amount of money, per hour. You could have dollars per pound, and pound is kind of weird, it's LBS. Dollars per pound. Now, where might you see dollars per pound? They might sell fruit or vegetables or meat or things at the grocery store for dollars per pound. You can have how many miles can you go on a gallon of gas? Which, so those are examples of different kinds of rates. They measure with two different kinds of units that measure two different kinds of things. So rates are usually written with the blank or y variable, the dependent variable on the top, followed by the independent variable, x, on the bottom. And finally, our last term is unit rate. A unit rate is a kind of rate or ratio where the second quantity or denominator is 1. So we're going to talk about, we're going to look at some ratios and rates, and they want us to determine whether the following is a ratio, a rate, or a unit rate. So there are 3 boys for every 2 girls in the club. They want us to write the ratio. That is 3 to 2. 3 boys, 2 girls, and that is just a ratio. Not a rate, not a unit rate. Because remember, a rate compares two different units of measurement, and a unit rate has a denominator, is a rate that has a denominator of 1, or the second amount is 1. Let's read the second one. Vaughn ran 19 miles in 2 hours. That's 19 miles in 2 hours. That is a ratio and it is a rate because the two things being measured are miles and hours. Miles measures distance, hours measures time. Next one, the car traveled 52 miles in 1 hour. Let's see, 52 miles, 1 hour, that's a ratio. It is also a rate. It compares miles, which measures distance, and hours, which measures time. And because the second value is 1, it's also a unit rate. There are 9 dogs for every 5 cats in a pet store. 9 dogs, 5 cats. Neither dogs and cats aren't really a unit of measurement, so it's just a ratio. The sign says the speed limit is 25 miles per hour. 25 miles per hour, that's 25 miles in per hour. How many hours is that? That's 1 hour. So that's a ratio, it's a rate, and it's a unit rate. Because the second value is just 1. There are 5 trumpet players for every 3 flute players. 5 trumpet, 3 flute, just a ratio. Janet rides her bike at an average rate of 14 miles per hour. That is 14 miles per 1 hour, right? 1 hour, that makes that a unit rate, which means it's all 3. Finally, 28 gallons of water leaked from the pipe after 3 hours. So 28 gallons of water leaked from the pipe after 3 hours. So that is a ratio, of course, but is it a rate? Well, let's see. What are the two things being compared? Gallons. Gallons measures amounts of water. Hours measures time. So it is a kind of rate, but it's not a unit rate because the second number isn't 1. All right, let's go on to the next page. Write the fully simplified ratio for each example. There are 20 blue erasers. Let's see. 20 blue erasers and 10 green erasers. What is the ratio of green erasers to blue erasers? So we want the ratio of green to blue. So the top is going to be green, the bottom is going to be blue. Ratio of green to blue is 10 to 20. But 10 to 20 can be simplified. I'm just going to divide the top and divide the bottom. Not by 2, but 2 does work. Divide by 10. And then you end up with 1 over 2. So that's just 1/2. 1 green, 2 blue. There are 5 pairs of white socks and 25 pairs of black socks. What is the ratio of white socks to total socks? 5 white, 25 black is the ratio of white to total. So they give us a ratio. They give us 5 white. You know what? I'm just going to use W for white, and they say 25 black. And they want the ratio of white to total. How do I do that? Well, if there are 5 white and 25 black, the total is just going to be 30. 30 total. And the ratio of white is still 5. So the ratio of white to total is 5 to 30. Actually, let me let me move that, because see if I can. There we go. There we go. So white to total is 5 to 30, but we can simplify. Divide by 5. We end up with 1 white to 6 total. There we go. 1 white socks to 6 total socks. Example 3. Jamie collects princess and superhero plushies. She currently has all 12 of her princess plushies sitting out on her shelf. 12 princess. If she has a total of 17 plushies, what is the ratio of princess to superhero plushies? Total of 17. So the ratio is 12 princess to 17 total. What is the ratio of princess to superhero? Well, if all the plushies are either princess or superhero, well then we can figure out the number of superhero plushies by just doing 17, the total, minus the 12, minus the princess. So 17 minus 12. So I'm going to do that on the side. 17 minus 12 is just, what is that? 5. So we've got 5 superhero plushies, SH. And they're asking for the ratio of princess to superhero. So let's write that down. 12 princess to 5 superhero. And there it is. 12 to 5. Last one. Or not last one, but example 4. Gabriel sells mango and guava trees. He has a total of 20 trees at his plant nursery. So 20 total trees. If 8 of them are guava, write the ratio of mango to guava. So they want the ratio of mango to guava. They give us a total of 20 total, and 8 are guava. There we go. And now they want a ratio of mango to guava. So how do I go from 20 total to 8 guava? Well, how do I figure out how many mango trees there are? Well, if he has 20 total trees and they're all 8 either guava or mango, that means it's 20 minus 8, which is 12 mango and 8 guava. But that can be simplified. So probably shouldn't have written it over there. Move that over. We can divide the top and bottom by, let's see, 2, and actually 4 also works. 4, 8, 12, that's 3 mango and 2 guava. The ratio of mango to guava is 2 to 3. All right, let's go to the next example. Students were asked by their PE teacher to go on a jog while recording their distance in yards and time in minutes. The table below shows the information given to the PE teacher. Answer the questions by writing a simplified rate. Remember, the dependent variable y usually goes before the independent variable x. What do I mean by that? Well, in a table, it's normally the x or independent goes first, y dependent goes afterwards. So, let's answer the questions. What rate is Gino jogging at? Where is Gino? Oh, it's in alphabetical order. Remember, y goes first, x goes afterwards, so it's 181 yards per 52 minutes. And they want us to simplify it. I don't believe I can divide this by 2. You can't divide it by 3 because 5 doesn't work, 7 doesn't work. I don't think this is divisible by anything, so that is our answer. What rate is Cindy jogging at? Cindy is right here. 270 yards to 75 minutes. I can divide that because they're both divisible by 5. Let's see, 75 divided by 5. My goodness, it's time to pull out a calculator. I believe that's 15. 15 minutes to 270 divided by 5. All right, trusty calculator, you are saying 54, and I do not believe I can simplify that further. So she runs at a rate of 54 yards for every 15 minutes. Let's go ahead and go down to unit rate examples now. A unit rate is a special rate where the denominator is 1. To find the unit rate, write the rate and make the denominator 1 by using division. For example, Alex jogged 225 yards in 50 minutes. So 225 yards, 50 minutes. How do I get 50 to turn into 1? So this is a rate, and I'm going to turn it into a unit rate. How do I get 50 to turn into 1? Well, you divide by 50, right? Because 50 divided by 50 gets you 1. So if I divide the bottom by 50, I need to divide the top by 50 as well. And 225 divided by 50, this is trusty calculator work. That's 4.5 yards per minute. And you may be thinking, wow, that's weird. You've got like a decimal and a fraction. Yeah, I guess, but it's a rate. So it's not really weird at all. So the unit rate can also be written as 4.5 yards per minute. I don't necessarily have to write 1 minute with unit rates. It's kind of assumed that when you say per minute, that means 1 minute. All right, write Abby's jogging rate as a unit rate. So where's Abby? Abby is right over here. 60 and 273. So 273, remember we want the independent variable, the y variable first. The distance, 273 yards for every 60 minutes. We need to divide the top and bottom by 60. Or really, I mean, I'm writing this over here, but really, you could just type in 273 divided by 60, because remember, this is like a fraction, and a fraction is basically a division problem. So 273 divided by 60 gets me 4.55. 4.55. 4.55 what? You cannot circle that answer. You have to tell me what the unit rate is. So it is 4.55 yards per minute. And finally, what was Faye's average jogging speed? Hint, speed is a unit rate that compares distance and time. Oh, so when they ask for the speed, they just want a ratio of distance to time. So Faye is right here. Distance to time, 202 over 60. 202 yards, 60 minutes. divided by 60. 202 divided by 60 gets me 3.36 repeating. It just kind of keeps going like this. So what I'm going to do is I'm going to just round it to the nearest hundredth. So if it's 3.33666, this means I'm going to round this number up. So I'm just going to write it as 3.37 yards per minute. And there it is. That is all about ratios and rates, which are a kind of ratio, and a unit rate, which is a kind of rate. Go ahead and try some problems on your own.